Hello, we are discussing about the video solutions for GATE 2013. The complete explanation for the questions appeared in GATE 2013. The topic is electron devices and we are discussing a series of 2 more questions. This is the second question what we are discussing. The question given is, in the circuit shown below, the silicon NPN transistor Q has a very high value of beta. The required value of R2 in kilo ohms to produce IC is equal to 1 milliampere is A 20, B 30 kilo ohms, C 40 kilo ohms, D 50 kilo ohms. I am reading the question again. For the circuit shown below, the silicon NPN transistor has a very high value of beta. The required value of R2 resistance in kilo ohms to produce IC is equal to 1 milliampere is. We need to calculate the resistance value R2 so that the collector current is going to be 1 milliampere. The right answer for this question is C 40 kilo ohms. If we place R2 as 40 kilo ohms, at that time the current flowing through the collector is 1 milliampere. We will see how to calculate this one. This type of questions will appear more frequently in GATE. So this is very important point to be remembered is high value of beta. Whenever it is given, beta will be taken as very large. That is nothing but indirectly it is going to be given as you can easily neglect the base current. So high value of beta is nothing but IB is equal to 0. We can prove like this. What we know is IB is equal to IC by beta, but beta is very large. So IC by beta, IC by very large is approximately equal to 0. So IB will become, base current will become 0 milliamperes whenever the beta value is very high. So simply we can neglect the current flowing through the base terminal, that is IB is 0. Whenever IB is equal to 0, the conclusions we can get from this circuit is IA is equal to IB plus IC, but IB is neglected, so that IA is equal to IC, that is equal to 1 milliampere, which was given. First conclusion. And it looks like IR1, the current flowing through R1 resistor, is going into base side as well as R2 side, but we can neglect the base current. So the current flowed into R1 is also flows through this R2 resistor, that is IR1 is equal to IR2. So high value of beta gave us two conclusions. One is same current flows in R1 and R2, same current flows through collector and emitter. Now we need to calculate R2 value. R2 value, if you want to know at that time, we must know the voltage drop across this R2 and divided by current flowing through this one. First we will calculate voltage drop across R2. Voltage drop across R2 is nothing but voltage across base terminal, that is voltage from base to ground. We are saying it as VB. VB is the voltage from base to ground. VB can be written as from this way. This is base. VB is nothing but VBE plus voltage drop across this RE resistor. So VB is equal to VBE plus IERE. VBE for the NPN transistor is 0.7 volts and IE is given as 1 milliampere and RE is 500 ohms, that is 0.5 kilo ohms. So the total value VB, base voltage, is given as 1.2 volts. Next we can calculate now IR1, that is also flowing through this R2. IR1 is nothing but voltage difference across this resistor divided by current flowing through it, or if you want to know the current, at that time voltage difference divided by the resistance value. IR1 is nothing but VCC minus VB divided by R1. VCC is 3 volts, VB is just now calculated 1.2 volts divided by R1 is 60 kilo ohms. The value we are not simplified, so 1.8 divided by 60 milliamperes. And the same current flows through this R2, so that R2 is equal to base voltage divided by IR1, that is nothing but base voltage divided by IR2. So 1.2 divided by 1.8 by 60, that is gives rise to 40 kilo ohms. So the value of R2 is 40 kilo ohms. The right answer for the given question is 40 kilo ohms.